Section 7.4 is about solving nonlinear systems of equations. And what that means is, before in Chapter 6, we were intersecting sets of lines on the plane. Now we're intersecting things that aren't lines. In this case, we're intersecting a circle with a line. So we might have more than one solution. We might have 2 solutions. We might have 4 solutions. But it's going to get a little more complicated than it was with just lines. For this section, you're going to have to actually use substitution or elimination. Usually substitution is the method we use here, but not always. So looking at this, the easiest way to solve this one is probably going to be solve this for x or y and then plug into this one and see what we get out. So let's solve this one for y by moving the x over. And now once we have this, we can replace y with x plus 3. Okay, remembering we need to keep that square on it. And now we just have to work it out. So I either FOIL this out or I remember the binomial expansion. Either way will give you that. And it is a quadratic, so let's get everything over to the left-hand side. And then to solve that, try to factor it first. And I don't like factoring with that 2 in front. I can if I need to. But I notice that these are all even. So what I can do is divide my entire equation through by 2. And since that's a 0, it's not going to change it at all. But if I divide my entire equation through by 2, it gets a little more simplistic. Now that's going to factor nicely. And I get 2 solutions. -5 and 2. Now the problem is these are solutions for x, and since I have an x and a y, I need ordered pairs. So let's see what happens by plugging the -5 and the 2 into this. So when x is -5, I get y equals -5 plus 3, or -2. That's one ordered pair. And the other ordered pair occurs when x equals 2. So let's see what happens there. So y equals 2 plus 3, or 5. And I found the 2 solutions to this nonlinear system of equations. Let's try one more. Okay, in this one, it looks like a substitution is probably better, more in order, because I already have a y squared here that I can plug in for the y squared there. Okay, so everywhere I see this y, I'm just going to plug in the x plus 5. And now I notice it's a quadratic, so I'm bringing everything over to the left-hand side. And simplifying. And again, that one's going to factor nicely. Which gives me a solution set of -5 and +4. But again, those are only my x values. So let me put my ordered pairs up here. Let's see what happens when I plug -5 in. And I'm going to plug into this one just because it looks a little bit simpler. So y squared equals -5 plus 5 equals 0. I can take the square root of each side and get y equals 0. So when x is negative 5, y equals 0. That was easy enough. Now let's try 4. So y squared equals 4 plus 5, or y squared equals 9. Take the square root of each side. But now, since I have a number here, I have to account for both a positive part and a negative part. So when x equals 4, y can either be positive 3 or negative 3. So I'll just have to write 2 ordered pairs for that. So this particular problem had 3 solutions.